All right, good morning, everyone. Good morning. Thank you for coming out. I'm Lynn Langit, and very happy to be in the Twin Cities. I'm based in California, but I am actually originally from Fargo. And I know, so take the cold weather, grew up there for 20 years, and I'm really happy to see this conference be in the Twin Cities. I'm actually here because of a talk that I did in Oslo. This talk, a version of it, actually 2 years ago. So if you have the opportunity and you're enjoying the conference, really do thank Jacob and Charlotte and the team. They selected the Twin Cities. I don't know if you guys know, but this is the only NDC they have in the United States. And I feel really proud to be a part of it. So thanks for coming out. All right, so the topic at hand, serverless architectures. I have lots to say about this. I am an independent cloud architect. I am based in California, but I've been doing work all over the globe, which you'll be hearing about. And in the 2 years since I initially gave this talk, as I was revising it for this conference, it was interesting to me to see how really basically all of my work included some aspect of serverless. I have worked entirely on public cloud architectures, building solutions with teams globally for about 5 years now. By way of background, way back in the Ballmer years, I actually was employed at Microsoft. Some of you might actually know some of my work there because I was an evangelist. And so I did a lot of presentations and talks all over the world. So I worked there from 2007 to 2011. And then when I left, I actually got much more involved, and that was right when Azure launched, actually, with Amazon, just because that was what my customers were really looking for in my particular verticals. And I also did some work with the Google Cloud. I have been running a nonprofit for many years. I've recently turned it over to another group. But in addition to my professional work, I ran a nonprofit to create software to teach middle school age children to code. It's still available publicly. And again, I always have to give a little plug for it because it's free. So that is teachingkidsprogramming.org. It is a set of open source Java libraries for middle school teachers, actually, to teach logo-style programming to our middle school kids. And the reason we use Java is because that's what's available at the AP level. Personally, I'm coding in Python like most of the rest of us, or Node, but that's, it helps get our kids ready. So one of the things, too, is I would love to see the teacher training effort that's been taken over by the nonprofit that has started subsequently that I'm just an advisor to, called TKP Labs, in the Twin Cities. We're currently in 16 states and 10 countries. So I'll get to the topic at hand, but we always have to talk about our future. I think it's really important. Also, I want to just make another plug to this community. How many of you know what this sticker is? Ministar, yeah. So Todd Gardner, who I'm sure a lot of you know, got me connected to the Ministar people, because when I was at Microsoft, I was involved in helping get funding for startups. And it's a personal mission to me to bring some of my VC friends out to Ministar, because I've been participating in it, and I think a lot of great startup work is happening here in the Twin Cities. So support Ministar. Okay, I have so much information about this topic. I'm going to be at this conference. This is the only talk I'm doing. I will be attending, wandering around for the entire time. So I'm going to ask that if you have questions, and you probably will, take a little note, and after the session, I will be totally available for any questions. I just have so much information. I want to make sure I give the audience the information. So hopefully that's okay with everybody. Also, I'll put my slides up. My slides, I'll have links in them. I'll post them right after this so you can just kind of think about the topic at hand. You don't have to frantically take notes or anything. Okay, so serverless is a big change, kind of a scary change, and there has to be a reason for the change. I do work globally, and I have been over the past 2 years doing actually a lot of work in Australia, and thinking about why we would want to change, why we would move to a serverless type environment, because there's a big cost to it. What's the benefit? So I have some stories from Australia. Some of them I've been involved in, some of them I just know about. So this kind of kicks us off. So in, it was like 3-4 years ago, the Australian government engaged with sort of a typical enterprise. I think it was IBM and Accenture. I could be wrong here. But big sort of enterprisey kind of cloud and integrator. and said, we're going to take our Australian census and we're going to modernize. We're going to put it 100% online. This is a huge project. And everybody's really excited about we're going to move into the modern world. Well, you probably know how this story is going to go, right? So the day that it was supposed to come up, that's what happened. It was a colossal failure. Like no one could log in, nothing. And it cost $9 million in 1 year. So how serverless comes into play here is there was, it happened to be an AWS summit in Sydney. And some young university students attended the summit and were introduced to the serverless architecture pattern. And they said, we think we can actually build something with a similar functionality to this, because it's just basically kind of a registration site, pretty simple functionality, serverlessly. So let's give it a go. And let's see if we could build it, how much it would cost, how long it would take, and if we could actually load test it so that you wouldn't have this kind of situation. And it took them $500 in service costs and 1 weekend. So, stories like this is kind of like what causes you all to come here, right? So because these kind of things actually are possible. But what my goal is in this talk today, based on my experience working with teams, is to help separate the hype from the reality and start to give you a path of how you and your organization might realize some of these economies that are possible in the serverless cloud environment. So again, I have links in my slides. So this is an actual true story, basically. So this was really, got a lot of people's attention in Australia. And it got the attention of a guy who had been working on a project. He had had a job, but the industry changed and he wanted to come into the cloud world. And so he studied, and he actually interviewed at Amazon. And he got asked, like, how did you study? Can you kind of make videos of what you studied? Because I want to get a job at Amazon. He actually didn't get a job at Amazon. Ironically, he failed the interview after all that. But he posted all of his training materials on like an EDX or a Coursera. And he said, and people were watching him. And he said, oh, this is my actual business now. Except I don't want Coursera to take a cut. I read this story about what I just showed you. And my brother is a developer at Microsoft. And my brother's coming home for holiday. So his brother's name is Sam. The guy's name is Ryan. Some people might know who these people are. Sam worked out that if he would be able to launch the school to market in 4 weeks, if he could leverage the work of others, with no ops team, 2 brothers, they knew they wouldn't be able to manage the infrastructure and scale quickly. In 28 days, Sam built, kind of the joke is, they're typical Aussies, they have just a ton of kids. I think they have 6, 7 kids between them. They said they locked Sam in their parents' office room, and it was a holiday, and said, you don't get to come out till it works. We'll manage the kids. Kind of funny. In 28 days, Sam built a complete learning management platform. He had discussion forums, payment processing. What companies spent years building using traditional server-based architectures, Sam built in 30 days using serverless architecture. This case was AWS Cloud. Some of you might know this story. They now have 800,000 customers in 181 countries. They like to say for the first 200,000 customers, they were on the free tier on Amazon. It's a cloud guru. Some of you might have seen some of their videos. They're very, very, very popular in terms of, and justifiably, in terms of preparing for certification. And there's real money behind this. This isn't a weekend hackathon project. They just got their second venture round, $44 million. So all serverless. They like to show at conferences, which they now run, their EC2 console, which is empty. They have no servers. So how do you start? Is it all Lambda? Is it all Amazon? Well, I would argue, and you can argue with me, that they really did start the category. It's very interesting. The biggest moneymaker on Amazon is their virtual machines, EC2. So they tell the story that the guy who came up with the idea for Lambda went to the head of Amazon and said, okay, we're going to time slice our virtual machines. We can make more money. Just like the airlines. We make the seat smaller, basically, right? And Andy Jassy said, you do realize that EC2 is our biggest moneymaker. And you are asking me to cannibalize our own money here. And the guy said, if we don't do it, someone will do it to us. Amazon are smart business people. So Andy Jassy said, okay, let's go. And so in 2014, they introduced Amazon Lambda, which is functions as a service. And in my world as a cloud architect, I immediately got requests for this. Immediately. So what is it? You hear all these functions, Kubernetes, Docker, VMs. How do you figure out all this stuff? I'm the kind of person that likes to have pictures in my mind. So this picture is helpful for me, and maybe it'll be helpful for you. So when I think about working with compute on a public cloud, and although I started with Amazon, everybody has functions now. Azure has had them. Google just went GA with them. Everybody has them now. So we have 3 choices to start with. The first is a virtual machine. And I think of this based on, the shipping metaphor. A virtual machine is the ship, the physical ship, the thing that says Maersk Line on it. It's a physical ship, okay? Container is a Docker container. There are other types of containers, but we'll just go with a Docker container. That contains your application. A function is some method that's running in a container. So one of the things that had been a big mystery to me when this first started was, serverless? What does that mean? Where are the servers? Who's running the servers? The point of serverless is there's servers. You just don't get to see them. You're abstracting at a higher level. Now, one of the things that's really fascinating in the cloud industry, because I do work across all the clouds, which is kind of a unique perspective, is it depends on which vendor you ask in terms of the maturity of their services, which is important from when you actually deploy. And there's a reason I started with Amazon pioneered Lambda. In my opinion, in my talk to get my opinion, Lambda or functions are most mature in the Amazon cloud. And so one of the things for you to think about from a practical point is if you're going to go serverless, you need to kind of start with Amazon and say, what do they have? And let me look at whatever cloud, whether I'm on Azure or Google or whatever it is, and compare to Amazon. I'm just, again, stating the news. I don't work for any of these guys. I work for you. It's important to understand Amazon has had first mover. They launched it in 2014. Google, of course, is where the market-leading container orchestration service, which is called Kubernetes, originated from. I just got back from the annual Google Cloud Conference. It was 2 weeks ago in San Francisco. And it's so fascinating to see that Google talks about serverless containers. Why? They like to work at the container level. Their functions just went GA, like literally 2 weeks ago. It's very, very important that you understand kind of the focus of the cloud vendors. So in this analogy, the ship is a virtual machine, the container is the application, and the dock is the controller or the Kubernetes. And the functions are running in the containers. So what does that look like from an architectural standpoint? Because this is a patterns talk. So again, this is an Amazon-based sort of drawing, but the functions are sitting on top. The containers are the next level down. The center is the controller, which would be the Kubernetes control plane, and the bottom is the virtual machines. So this is the general pattern, just to start to get a picture in your head. What does this look like from an architectural point when you start thinking about a serverless architecture? Well, when you're thinking about it and you think about compute, you have a continuum to think about. Obviously, we start with bare metal, the vendors managing the bare metal. This is an Amazon drawing. And they have a managed service called Lightsail, which we don't really have to worry about. So we have EC2. We have our virtual machines. What sits on top of that? Where are our decision vectors? This is where you're really thinking. And what it really comes down to is if you're going VMs, fine. Fine, great. Then you're not serverless. Fine, different talk. If you're not going VMs, it's a decision between are you operating at the function level or at the container level. This is sort of the critical compute decision. My opinion is if your workload is such that you can support stateless functions, because functions are stateless. You want to start by thinking about functions and let the vendor manage as much as possible. There are many workloads that won't fit for. And sort of the first thing you think about is, when you're working at the function level, who's making the container? The vendor, right? So if you need a container that has X, Y, and Z, then you're probably going to have to work at the container level. And I'm going to show you examples of work that I've done on both sides, so you can have actual practical examples as well. Now, at the container level, what's fascinating is Kubernetes is hard. Containers themselves, I don't think, are that hard. I don't know if you'd argue, but I don't think it's that hard to Dockerize something. What I find to be difficult is to properly scale and orchestrate and secure Kubernetes clusters. I think it's really difficult, and I've been working on it for 1.5 years. It's all sort of new stuff. It's not VMs, it's not functions. It's a lot of effort. So what has been fascinating is the cloud vendors are starting to supply partially managed container clusters. Azure, of course, Microsoft Build's going on right now, and Azure announced some of this yesterday. Google announced some of it at GCP Next. Amazon's version is called Fargate. Now, it's fascinating because it's very much a difference in the vendors. Amazon now supports Kubernetes, but not as deeply as the other vendors. They have an alternate container service called Elastic Container Service, which is not Kubernetes. And that's important when you're thinking about compute and potentially serverless, because this is proprietary to Amazon. I'm not saying it's bad, I'm saying you just need to be aware of it. So when you think about compute, you really have 4 options. You have VMs and you have functions. But you have either you manage the container clusters, which is Kubernetes for most people, or it could be ECS or Kubernetes for Amazon. Or what's really interesting to me is partially managed containers. This is kind of the new. Because in the past, I would have gone functions, or frankly, probably VMs, unless there was a compelling reason to use Kubernetes. And the vendor product offerings are starting to reflect the fact that Kubernetes is hard. So Google announced a couple of things last week that I'm actually going to show you because they're very interesting. Because, of course, they made Kubernetes, so they're probably going to have the most usable optimizations, called Cloud Run and Cloud Run on Google Kubernetes. Very interesting set of services that give you an alternative to pure functions. But before we get to the alternative, I realize that I'm maybe getting ahead of myself. I should probably talk about pure functions. So again, this is a patterns talk. When you're working with functions on the cloud, just like functions on-prem, you're doing eventing. So I'm sure many of you are working on-prem with eventing type models. So you basically take all those architectural patterns of you have an event source, so you have sinks and triggers, and then results. So you have event sources and functions and services. The function is called glue code. Somebody said it's like the Unix pipe. It just pipes things together. That's what Lambda is in some ways. That's what Amazon would have you do. It's not necessarily the reality. So we'll look at the simplest possible thing, which is you have a response to an endpoint that invokes a function and sends information down the pipeline. Okay? So let's just do that. I set some up for you. This isn't going to be a super demo-heavy talk, but I know sometimes it's good to see things. So if you create a function in Google, you set the only lever that you have is the memory. A practical thing is if you're having problems with performance, whether it's memory or disk or whatever, if you set the memory higher, you get more CPUs and you get more disk. That's the way the functions work. From a triggering standpoint in Google, you have 2 types. You have a HTTP or you have a somehow integrated one of the Google services. So for example, the other sort of simple canonical use case is you put a file in a bucket and then a function will run. And then for the code, it depends on the vendor. Of course, Google is probably the only place you're going to see Go, right? Because they love their languages. Everybody has Node and Python. And then, of course, Microsoft's going to have C#. and Amazon has all this except Go and Java. And then, because you are devs, so this is an asynchronous pattern. So you're exporting this function, request response, and you're just going to get a hello world back. Okay? Pretty easy. So you're hitting an endpoint. So inside of here, you're just going to trigger it. You have to do hello world, or you're not legit, right? Hello world, hello world, hello world, and let's trigger it 27 times. Again, on functions, you don't see the container, you don't see the VM, you pay every time I click the button. And it's 1/100th the price of a VM, basically. So then you look at it, and this is super important. You can't SSH. You can't connect to the container. You can't connect to the VM because it's ephemeral. All you get is the log, okay? So it's so fascinating that the costs of this, when I've worked with teams, you know, all the managers, and I'm telling you the real here so you can go back and have the ammunition you need to really understand this. The service costs are 1/100th, okay? But the training costs are like a lot. Because how do you, if you've never been in this environment, deal with programming where your feedback is a log? Like particularly in Google, there's, as far as I know, there's no local version of this. You test on the cloud, which there's a cost to that. There's a training cost to that. So anyway, so logging is super important in serverless patterns. Having developers understand how to work with logs, have log readers, have log reader tools. You might have to buy third-party log reader tools. And then for some of the other clouds, Azure's always been the best for this. Azure has local versions of everything, which is actually really important for dev feedback, right? So Azure Functions you can develop locally. The way Amazon works is they have big community, and so they have SAM local. So you actually can do Lambda local, but you have to get third-party stuff that you download. So, all right, just to show you Lambda. Probably should have started with that, but oh well. So here's the Lambda Council. If you create a function in Amazon, you author from scratch, use a blueprint, which is basically a script file, or there's a new thing called the Serverless Application Repository. And this is actually shows Amazon's market leadership. This is a CloudFormation template. It's a YAML or JSON file that is an application. So it will have Lambdas, it will have security objects and other objects. And actually one of the projects I did over the past 2 years is I worked with a company called Here Technologies. They're a competitor to Google Maps. And I helped build, well, I'll show you. I helped build SAM templates. So I'm not going to have a huge amount of time to go into that, but it's actually a really important pattern. And if that's an interest to you, I can talk to you about it. But anyway, so let's go and look at a function here. So here's my function. Amazon already shows you like a visual interface of what are the triggers, and they have more things you can trigger too, and then where's the output. And then this is just a hello again, so test. And then when you're done testing, you have a little monitoring interface here. Of course, you have CloudWatch logs, which are going to look similar to the Google logs, but Amazon provides you with a tool. You have to turn a switch on in the Lambda, which I did, called X-Ray, which is a log reader. And once it catches up, which is a difference between Google and Amazon, there we go. It's a visualizer of the logs. So you can see you have startup time and you have duration. And then if you click into it, you can see the bottlenecks. So this is what I'm talking about in terms of the price of functions is cheap, but it's a new way of deving, right? And I know I have a dev audience here, so I wanted to show you this, even though it's patterns talk. The cost is new techniques and new tools, learning them. So, all right. So what is serverless? You need to pick the service on the cloud vendor, whether it's Lambda or something else, for compute, for data, or other things like security or machine learning. You are going to write the code, the function code, to call stateless functions. They're going to execute on event triggers. You're going to pay only on execution. So your service costs are going to come way down. but there are other costs. You scale automatically. There's no load balancers. There's no auto scalers. It's done for you automatically. So a question I get from my C-level people I talk to is, okay, well, is it just Lambda? Is Lambda equal to serverless? Is that it? You just do Lambdas and you're done? That is so not it. Lambda is, I'm kind of mathy, proper subset of serverless. So this doesn't represent at all how many services. Amazon has like 200 services, and they probably have 150 that are serverless. So what are these services? Well, tables as a service for DynamoDB. Security keys as a service in encryption. Machine learning as a service in recognition. What's really interesting when you start to build serverless application architectures, you not only have to think differently about where you put your compute, you need to think differently about build versus buy. Because what I see a lot of companies doing is not investing the time to understand the serverless services that are made available. And if they don't work for you, fine, write code. But I've seen code for services that are available on the vendor platform, which makes no sense, you guys. It makes no sense. You should at least look at what the vendor has. So the first serverless service wasn't really Lambda. It had to do with data. It's S3. So S3, of course, is just putting objects in a bucket, and that's Azure Blob Store or Google Cloud Storage. So this really is the first key pattern. I know it took a little time to get here, but this is the first key pattern. This is sort of the canonical serverless architecture. You put your objects in buckets. You interact with them with Lambda functions, one function basically per each method. You put any sort of data you want to query against in NoSQL tables as a service in DynamoDB. And then you're going to have IAM roles, which are going to secure each of these objects. And I kind of made it simple. The best architecture is you have one role per object. And if you're public-facing, you'll have some sort of gateway to make a REST interface. Now, I was teaching a workshop over the past 2 days, and I had a very wonderful class. And one of my quiet, it's always the quiet ones. One of my quiet students said, wouldn't you have like a lot of objects here? And the answer to that is yes. So one of the things that is really important to understand in terms of serverless architectures is you go from having a database server, a middle-tier server, and an application server, right? Typical three-tiered architecture, or clustered or whatever, to hundreds of objects or thousands of objects. Now, you're not going to go in a direct path, okay? Especially if you're migrating off of something enterprise, you're going to slice off functionality and do a Lambda. But deployment becomes completely different. And again, one of the aspects of working in production with serverless is the function of what the technical people do changes. First of all, to have success, you physically need to sit together. So no more of this developers over here and DBAs over here and network admins over here. It doesn't work. You need to get people to sit together so you have the people writing the code and then you have the people pushing the code to different environments. It's DevOps, right? That's what DevOps really looks like. But it literally is the people sitting together so you can have a faster iteration. The other thing is no more clicking on the console. You have to capture all of your configuration code as code and check it in. And I've seen actually in organizations where the configuration code is 3 times the amount of code as the function code for Lambdas. Literally, developers have gone over to the DevOps side. And you say, well, I don't want to write YAML. I'm not a masochist, But there's tools, basically, that you use. But to truly create a serverless enterprise application, which one of the jobs I was on, we did an enterprise IoT. It took 14 months total, 10 months to ship, which was pretty good. And we built a CI/CD pipeline. We had 4 Amazon environments. And we had, 500 objects. So figure out what that configuration code looked like, right? You lose a security key, you're kind of hosed out there. What does this look like on Google? Well, Google, for some reason, doesn't like color. I don't know if it's an engineering thing or what, but it's basically the same thing. And again, if you're Azure, because I know a lot of people here are Azure, there would be an Azure blob store for the bucket. Bigtable would be Cosmos DB, and the functions would be Azure functions. So this core architecture is basically the same. So why do you use this? We'll talk about why you use it and then why you don't use it. Well, A Cloud Guru is a really good example. So they are a startup, and they had training videos, and they had no idea if they're going to be successful or not. But they had kind of a high compute workload, serving up videos all over the world. And so they had a potentially huge volume. They had dynamic workloads, and they wanted to schedule notifications to their students. Bursty workload is a really good use case for this. If you have sort of steady, might not be. All right, so the first big serverless project I did, like I was just saying, was enterprise IoT. The use case was, it's Hunter. I can tell you the company, Hunter Industries. It's sprinkler controller, you know, like a box where you control the sprinklers on a golf course. So they had competitive pressure from startups that had IoT enabled, and especially after Troy's talk, this will be relevant if you guys went to Troy's talk this morning. And so they had 200,000 of these devices in market, and they were getting trumped by competition. They also had a failure. It's always motivating to enterprise if they have a failure, because they had 10 people, I think it was 10 guys, 3 years, tried to build it in-house, shipped nothing. And so they fired them all. They took the little group that had been doing kind of a DevOps kind of thing and said, okay, company needs this. Brought me in because I knew Azure and Amazon IoT and said, we're going to go cloud. We got to do it. So it was interesting because, you know, on the right side here, we have kind of that typical architecture, how you start. You know, you have security, you have tables, you have Lambdas, you have a gateway for the phone app, right? We had also Cognito for ID. And we thought the left side is going to be the big risk. The left side is a specialized message gateway for IoT. This is a new product, and it has a specialized control of certificates for security and all this kind of stuff. And although it wasn't without challenges, what actually in the project was super challenging was the right side. And it was because basically the teams had to unlearn so much. It was a .NET shop doing WinForms internal apps. The team that we were working on the project, C#, never done a cloud app in any way, shape, or form, had no CI/CD. And I was just going to do the architecture and then leave. But I thought, this is kind of interesting. I'm going to stay here and see how it goes. And what we ended up doing is we got to the architecture on the right. We got to, I guess I can point to it. Maybe. I don't know. Yeah, there. We got there, but we took kind of a circuitous path. What we found with using NoSQL, which is serverless data, was too hard and didn't add value. So we actually started out with a server-based. We used RDS, MySQL. So again, I'm just giving you some real, like how you get there. Because NoSQL queries are NoSQL, they're hard. And we actually timed it and took 4 to 5 times as long as to do SQL queries. And so we actually started with DynamoDB, we ripped it out. And then we went to server-based until we went live. So it kind of was in and out. Sounds weird, but it actually worked. In terms of Lambda, it was interesting. They didn't know Node. And we went with Node because of some challenges with Lambda in Java or C#, which I'll talk about in a minute. But they didn't know Node, so we hired some contractors, and the contractors didn't know how to program serverlessly. And so they just, you know what contractors will do. They said it was impossible, right? So I politely showed them, and we started with what are called micro VMs, just to get going. Micro VMs on Amazon cost $5 a month. So again, these are like patterns from the real world. Sometimes you have to have interim steps, because if you make micro VMs, you're getting people to break your monolithic applications down to functions. Do you know what I mean? It really was a very useful thing that we did. Now, just to kind of complete the story, we did, once we got a Lambda going, we needed to get new contractors. So, you know, there's that too. But It was interesting because we really thought the left side was going to be the challenge, but it was kind of unthinking the relational databases and the monolithic applications. So we ended up using both EC2 and Lambda. We did use S3. The only challenge there was setting up the policies. We went with RDS, and then we used the IoT broker, so we used the specialized broker for IoT. And the reason for that was that security was built in for some of those things Troy was talking about. It was much better than just using a pub sub or the open source thing. So what did we learn in that project? We shipped in 10 months, okay, so big deal. But we had all these costs. So the team had to learn Amazon. And we did just-in-time training for the devs. They didn't want to go to certification. We converted to server-based, based on pain. We had to learn how to do custom security policy for proper security, because we did do proper security, by God. You can go and test it. I was just determined I wasn't going to be in Troy's talk. But it was hard. I mean, we had to do dynamic policy variables and all kinds of stuff. So there was programming around security policies. We had to figure out how to test. Amazon is not well known for having its services local, so we had to mock everything, which in hindsight, I'm not sure was the right thing. I think we should have moved more quickly to what's called observability and looking at logs. We had to have the developers move to a functional pattern. There's lots of talks about that. It's really hot in the industry. That's a real for serverless. You have to program in your language in a functional way or it's not going to work. Modularity. We had to learn how to call APIs. Patterns of distributed systems, eventual consistency. Hard. Very, very hard. Unreliable systems. We had to write an exponential backoff for the security authentication. Message passing. Our people had to learn DevOps. We had to physically move the network admins and the DBAs in. For the first time the team put up an RDS server, the dev team, they said, oh, we just want to get it up and going. I said, you better not do that. 15 minutes, Bitcoin mining. Then the network admins got their butts over there. We had to learn CI/CD because we had too many artifacts we couldn't deploy. It was impossible. We actually used the Go CD server, and that process took us, out of the 10 months, the CI/CD to get that running across the 4 environments, because I did that with the team. 3 months. Okay, I'm not joking when I say the DevOps part of serverless is hard. We got it. Push to deploy. And product owner can check it before it goes out. Just hear what I'm saying there. 3 months for the CI/CD. Build deployment pipelines. Configuration as code. Observability and testing. Get them to read the logs. And this is key. We lost people. Not everybody made it. Change is hard. True benefits. Automatic scalability. We were able to go to 200,000 devices. Woohoo! Throttling, reliability, reduced infrastructure. We didn't have servers. The project succeeded. 10 months to beta. President of the company was watering his lawn. 10 months. It worked. This is the big win right here. Subsequently, the team has had big wins in cloud. So with serverless, like any other change, you have this very hard initial thing. And then once you have success, then you get the payback. But the first project is very hard. New features out faster. We can A/B test. We're doing the cool CI/CD deployment pattern. You guys are probably familiar with some of these, where you put out a feature to a certain % of people. So we're getting the benefits. Security. And there's happy team. Yay. So this is one of the key takeaways from this talk. Key to turn serverless architecture into usable products is consistently and effectively implementing DevOps. I really cannot stress this enough. That's why I actually said I would give this talk, because I always try to add to the space. I just don't see this being talked about enough. I see, make your code functional and da-da-da. Yes, you have to do these things. But honestly, the really hard part is the DevOps. Really hard part. Okay, so buoyed by my success, I had a big change in my career. It started from a sad event. A friend of mine got cancer. about 2 or 3 years ago. She's okay, but she had horrible chemotherapy. And my daughter's going into bioinformatics. And so she was up at Stanford, and she came back from a summer at Stanford and said, Mom, these people don't know how to use the cloud. And I was like, oh, well, okay. This is what I'm going to do now. And so for the past 2.5, 3 years, that is all I've been doing. I started from nothing, and I just went to Google, and I said, okay, what can I do? And they said, there's a lot of work needed around building serverless pipelines, and guess what? DevOps. And I was like, okay, I can do that. So when you're building cloud data pipelines, the first thing you have to think about is data. So it could reflect my bias. I don't know if some of you know my past work, but I wrote 3 books on SQL Server. So I really am kind of an old DBA that kind of is coming into the new world. So I always think about data. And one of the things I see not thought out enough in serverless projects is where's the data, how should the data work? So I always start kind of here. Like, what kind of data do you have going on? Because one of the benefits you get from serverless is scalability. So you can put more data in, okay? So files, SQL, edge data, specialty, NoSQL. So I do a lot of work around NoSQL because it's hard. Modeling is hard, working with it is hard, bringing it in is hard. JSON data, for example. So this is what the world really looks like. And what I moved into from IoT was genomics, so data coming off sequencers. Specifically, I'm working with big research groups to help create reference data sets for types of cancers. And what they need is they need faster feedback. So burstable workloads, cloud, right? Okay, so Australia again. I don't know what it is about Australia. Keep going to Australia. So I was like, okay, I want to apply this serverless pattern because I know all these bioinformatic people, they have, like clusters and kind of old thinking, right? They have, libraries and stuff. So I was reading, and I read this. This new bio tool, GTScan2, leverages the instantaneous scalability of the event-driven Lambda service offers. This is crucial for personalized treatment as complexity of the targeted gene can vary dramatically. The off-target search, as well as the robustness analysis, can be subdivided into independent modular tasks that can run in parallel, said Aidan O'Brien, who designed and implemented the system within weeks after its official Asia-Pacific launch at the AWS Summit. A typical job takes less than a minute, and the variation between jobs from 1 second to 5 minutes. The fast fluctuation in load over minutes rather than hours ruled out EC2. So this was one of the first implementations of a kind of pure serverless architecture, kind of what I showed you in the beginning, the buckets and DynamoDB and Lambda and API Gateway used for bioinformatics. It's called GTScan2. Again, these Australians, they have this independent streak I like. Aidan, this guy, went to the summit. He said, I think I'm going to try that, and he built it. And Amazon was so impressed, they published it on Jeff Barr's blog, who's the lead evangelist for Amazon. It's like the Scott Hanselman, here a .NET person for Amazon. And I was sitting on my couch reading it, and I said, this is amazing. This is fantastic. The only thing that's different from reference architecture is they put in a queue here, there, the SNS queue for bursting, so they could burst. It's the nature of the scan. When you get to a certain point, you're going to burst for more data. Okay? Again, what the actual thing does doesn't really matter that much. It's more a pattern you guys can take for burstable workloads. And so I was going out to Australia for another reason, and I reached out to these guys, and it's a CSIRO, Commonwealth Scientific Industrial Research Organization. It's kind of like the National Science Foundation, but for Australia. And I said, I want to meet you. This is interesting. And they said, well, we're having some problems with Lambda. And again, this is important for you guys to know as a pattern. Think about what I said. When you're working with Lambda or functions, you don't control the container. So it's a very known problem and very important in architectural patterns. If you have to have millisecond kind of latency, you're not using Lambda. Because the container has to start up, and you're not starting it. It starts whenever the vendor feels like starting it, okay? There are, of course, Lambdas are not stateful. And because you're in a shared tenancy, you will sometimes get mystery errors and freeze and thaw errors. So you have to have retry logic. So some of the things I knew about, there's some patterns. You can do a warming trigger. in Amazon. You can use an external state store. And of course, there's always, kind of the version of restart, reboot, reload for Lambda is just make the size bigger. Just make the size bigger. You can always try that, right? And then just kind of informationally, Amazon seems to optimize for the latest version of Node always. Well, and use shorter operations. So I had shown you earlier, just briefly, this X-ray tool. And even that simple architecture you just saw, they were unable, using logs, to detect the bottleneck. They were unaware of this tool. So I showed them this tool, and immediately they found that one of the Lambdas was causing a bottleneck, rewrote it, and got it 80% faster. So again, it seems sort of like, why are you talking about this in an architecture talk? Because it's important that you understand you're going to work differently. And you need to have tools to read your logs, because that's what you get if you're doing functions. All right. So now you might be saying, well, I'm not doing functions. That's what I'm getting out of this talk. I want control. I'm a developer. I want containers. So then you'd be thinking probably about Google or Azure. Because frankly, Amazon is really optimizing for functions. Their story on Kubernetes is weak to non-existent. Isn't it great? I can just tell what I see as the truth. It's one of my most favorite things. All the companies want to hire me, but I refuse to be bought because I prefer to work for my customers. It's really a lot of fun. So Google literally says, yeah, you can have functions, but they're very limited in their use. You'd probably want more control. So they came out with this new thing last week that I think is really interesting. And I think it's going to be very useful. I think Azure has stuff like this. I just literally haven't had time to look. So their thing is Cloud Run. So if you look in Cloud Run here, you can see that they say, if I can see here, over here, put your container. GCR is your container registry here. And they say, list your container. You could use Docker Hub too, any container registry. And then you just put your container in there, and then you get it, basically. You get what? You get a Kubernetes cluster. So here's the container, and if I want to run it, I run it, no big, right? What's so fascinating about this, and you have your logs, of course. So it looks like a Lambda. The difference is what? You bring your own container. Why does that matter? What if you want to optimize your container because you're in a certain runtime and you have a lot of experience with this, as I'm sure a lot of you do? This is a great service. This is something I've been wanting for my customers for a while. So interestingly, you have two versions of this. You have the version where Google just basically still abstracts all of Kubernetes for you. But this is so fascinating. They have, on top of Kubernetes, made a library called Knative, which is basically an abstraction layer that helps with writing these service files and can be run on Kubernetes. So the idea here is that if you're needing more control, and I realize this is not serverless, although Google will tell you this is serverless containers right here. I don't, kind of. But if you move this Cloud Run and you put it on Google Kubernetes Engine, then you can control, for example, more about the resource allocation, which can impact the performance of your application in areas that are critical, like startup time. So it's very interesting to me that they've provided this greater level of control and said functions work for certain types of problems. VMs are obviously there. We want to give some options around Kubernetes. I am very, very, very interested in this for my customers that want and need more control. And I think it's an important thing for you to think about. All right. So in terms of pipelines, it's really fascinating that by default, Google is kind of serverless all across the board. They're serverless in terms of their functions. They're serverless in terms of their data, whereas Amazon has been serverful. Very specifically, their top data products allow for lift and shift because they've been around longer. So relational database service, which supports, of course, SQL Server, as well as MySQL and Postgres, and Redshift, which has been their big data warehouse killer for a long time. It's a column store. Last year at reInvent, their annual conference, they announced that both of these things have a serverless capability. This is a very, didn't get enough notice announcement, because the second highest revenue stream for Amazon is RDS and Redshift. They're expensive when you put a lot of data in there. And so what customers had done in the past is they started out and they got cloud economy, great, and then they just kind of put all the data in there, and all of a sudden, oh my God, my RDS bill is so big, right? So again, I love to see what the vendors are doing to each other, which helps us. Google has a serverless SQL service, 2 of them actually, that lacked some features for enterprise up until a year and a half ago or so. And Google has really added features, which has caused Amazon to say, we're going to add a serverless component to RDS and Redshift, which can allow the price to come down. Now, why am I talking about this in a serverless talk? Aren't you just supposed to use DynamoDB and be done? Remember what I said? Is DynamoDB easy to use? No. So this is a nice alternative in an architecture where you want all the transactional semantics of ANSI SQL. You can, again, leverage all of your skills in writing SQL queries and indexing and all that, but Amazon's very smart. You can archive off, because that's usually what it is, data into S3. It's sort of like partitioning. And you have to have the core RDS engine, and then you can move some of the data and then dramatically reduce the price of your cluster. So you're welcome, everyone here. I normally charge people a lot of money for that information. So again, the general pattern is ingest and prepare, and then query and present. One of the things that has been really interesting is to see this sort of move towards serverless. Amazon's giving you guys a path by server-based and then extending it. Google is just saying, just go completely serverless. All right, stories from Oz. Another story from Oz. Can you believe all these stories from Oz? I'm in an airplane a lot of times, let me tell you. So, the current Spark-based machine learning libraries are optimized for big customer data, which has very different properties than genomic data. Most notably, genomic data has vastly more information per sample. It's called the curse of dimensionality. Human genome is 3 billion letters, so it's extremely wide. We hence developed a new random forest implementation that allows the data set to be split not only vertically per sample, but also horizontally. Maybe I'm doing it the opposite way, but you know what I mean. So they split it. This allows for efficient utilization of memory and compute resources and makes advanced multivariate machine learning application possible for genomics, wide, and big data. Cursed forest will be the next version of Variant Spark. So, I like hard problems. I worked with this is CSIRO again. I worked with CSIRO on their GT scan and helped them get it 80% faster, pure serverless. So they had this library, Variant Spark. It's a Scala-based machine learning random forest library. And it was run on an on-prem Spark Hadoop cluster. And each run, when they could get time on the server, took 500 hours. And I'm not kidding. And they're building an ALS data set, so the Ice Bucket Challenge, a reference genome set for that. And I said, that's not good enough. I've worked in some crap industries, ad serving, and useless, but they're optimized, right? And I know that we can make this better. So this is the project I've been working on, not full-time, but pretty solidly, to make this faster. And I'll do the TLDR so you'll pay attention. We got it down to 10 minutes. We did not get serverless. So this is an example of, as we go through the detail of this, how you get partially serverless and how you decide what parts of the architecture are serverless. From a high level, because I know I'm presenting a lot of information fast, there's 3 parts: compute, data, and other. Compute, you're going to start at functions, look at VMs, and only look at Kubernetes if it adds value. That's the Lynn opinion, and you can go argue with me in the hall, and I'm sure people will argue, that's fine. From a data standpoint, you're going to always use an object store if you can. and then you're going to figure out if you're going to use a NoSQL store or you're going to try to do some kind of serverless SQL store. Other is where it gets kind of interesting. What the heck is other? It's security, it's machine learning, it's analytics, it's visualization. You need a lot of value. So let's look at this. So we started out with this problem by just doing a lift and shift. So on the right side here, you've got Elastic MapReduce, which is managed Spark. We just built a cluster. So VMs, basically, managed VMs. And we got some good value out of it. So again, one of the things to take away from this talk, I know patterns, and you're probably thinking, okay, I want like the invoker pattern and all that. I'm more of a practical gal. I'm trying to give you patterns for actually building the stuff that you can get to. So hopefully you find value in that. But one of the patterns sort of generally is you don't go straight to serverless. It just doesn't work. You have to give people a path. So what we did here is we built an EMR cluster, and we took advantage of some of the vendor stuff like spot pricing so we could burst. So we got this down to like 3 or 4 hours. Not bad, right? And we got the configuration data into S3. What we were able to get to was using Kubernetes. It was a fascinating set of work. I've written it up on Medium, and I have all the source code. Because Databricks, who runs Spark, made Spark available to work with Kubernetes. You don't have to use Yarn. And most importantly, the serverless part that we got done is right there, the data lake. We have no HDFS, which was really, really fascinating and provided a tremendous value to the customer because it took the price down, I don't know, by a factor of 3 or 4. And we also could do it more efficiently because you could spin up and down Docker containers much faster than virtual machines. That's how we went from 4 hours to 10 minutes. So in this particular architecture, the data portion became serverless, which again, I'm trying to actually make you think differently. I know I'm talking to a room of programmers, and you're probably going, I don't care. I want to see the programming portion. But what I'm saying as an architect is serverless architectures have compute, data, and other. And if you don't consider all the pieces, you're not understanding how you build these solutions. So this is called a data lake pattern. One of the other things that we really learned is we picked a configuration language, and we picked Terraform. And the reason we picked Terraform, this is really important, this is as important as picking a programming language, is because it's important to this use case that they can implement on Azure or GCP or Alibaba. And if you lock yourself into a vendor-specific configuration language, it becomes, if that's a business need, it becomes harder to change. And again, I think that's something that as a developer you probably haven't thought about. You probably thought, well, I want to do C#, I don't want to do Node or whatever, but you want to think about, do I want to do CloudFormation, or do I want to do Azure Resource Templates, or do I want to do Terraform? Okay? It's really important learning. All right. In fact, the next set of work on this will be on Google, because we can. And we're going to do performance comparison. So just as if you're interested in this data lakes or problem space, we'll be publishing on it. So the compute options here, we worked with EKS and GKE. All right. One of my favorite services that's available that people just don't know about is BigQuery, serverless SQL. And I'm aware I'm getting light on time here, so I'm going to go quick. So this has been out since 2011. This is SQL query on an object store. So you can see 150 gigabytes, and this might be cached. You run it, yeah, I think it was cached. It took 1 second. And then you have integrated, explored, and Data Studio, which is also serverless. So Google has had this for a really long time, and it didn't have the enterprise finish. It didn't have the import tools. It didn't have, I'm just kind of randomly clicking here so you can see. It didn't have the visualization tools. It didn't have, most importantly, the security tools. Remember how I said Amazon was being challenged by Google to provide serverless for RDS and stuff? This is what drove that. So this is now enterprise ready as a data warehouse, in my opinion, which is a big thing to say. And it's very fascinating to look at how the project space of genomics is benefiting from this. So this example I showed here, not the one I ran, but just an example that is on their public information, is 4 terabytes of data, 85 million rows. You can run your query in 30 seconds, and it costs $5 a terabyte. No servers, no scaling, no nothing. And very fascinating, they have now added machine learning. They have SQL extensions for doing logistic and linear regression models, k-means, and TensorFlow. This is really, really innovative and will drive what's going on in the industry. The idea is SQL on a data lake, including machine learning. All right. So in the genomics world, I've got that messy, sloppy pipeline that is not fully serverless. I've been very fortunate to start to work with the Broad Institute at Harvard and MIT. And they run the biggest workloads in Google Cloud in the world, 17 terabytes a day. And they currently have a Kubernetes-based pipeline, but they're working with Verily, which is a Google partner. And this is the vision, which is a fully serverless genomics pipeline, which will be nearly instantaneous. So you've got Google Cloud Storage, which is the data lake, Google Genomics, which is implementation of Apache Beam, and you have BigQuery on the front. I think this is the future of many types of serverless workloads, and I'm really excited to be a part of it. And I'm really interested to talk to any of you that want to talk about working this way. So, 1 minute over. If you want more of me, I have an almost 3-hour course on lynda.com, which you can get for free if you've signed up for 30 days, and then you can quit, I don't care. And then the guy from A Cloud Guru wrote a book about their architecture, and he's revising it, very nice guy. And there's a guy from ThoughtWorks that has written a wonderful article on principles of serverless compute, because I know that you guys want a lot of information about that. So I'm right at time. Thank you for paying such good attention. I hope you found this useful. Thank you.